Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Honor today to have Michael Terry drop in. Michael Terry is professor in the David Cheriton School of Computer Science at the University of Waterloo. University of Waterloo provides us with many fabulous researchers and SDEs throughout Microsoft and at Microsoft Research, a few of whom are in my team. He's a co-director of the Human Computer Interaction Lab there. He did his PhD work with Beth Minot at Georgia Tech, graduating in 2005. And his research focuses on developing, deploying, and evaluating tools that support usability needs in free open source software development. I guess that excludes you from all Microsoft tools and software, but we'll listen to you anyway. Michael.
Thanks. Thanks for the introduction. So I'm going to talk about some work we've been doing instrumenting GIMP, collecting data about how it's used in practice, and then what it means for the design of user interfaces. I encourage you to ask questions throughout the talk. If I know what it is that interests you, I can cater the talk towards you. All right, so I want to give you a quick overview of the lab. So as Eric mentioned, I co-direct the HCI lab at Waterloo. My co-director is Ed Lank. He tends to do work in motion kinematics and target prediction, so being able to predict what target someone is going towards as they start moving the mouse. And he's also doing a fair amount of work in pen math computing these days. As Eric mentioned, my particular research focus is looking at usability practices and processes in the free and open source software community. To date, that has really focused on instrumentation work and then also describing how the community thinks about usability and practices it on a day-to-day basis. But as a result of the instrumentation work, we're moving towards adaptable interfaces based on the data that we've gathered. I want to give you a quick sampling of some other projects that we've done in the past that may be of interest to you. So we've done some work detecting and correcting awkward language, and I'll show you examples of that in a second. And we've also done some work redesigning license agreements, which has been a really fun challenge, actually. So if you're a non-native speaker of English, you might say something like, "Is the sky pure today?" when in fact you mean, "Is the sky clear today?" Or you might ask, or you might say, "Let's leave to the beach and take walk there." Or you might say, "I will try to draw a picture from the view." These are what are known as collocation errors. They're awkward phrasings, but they're not grammatically incorrect for the most part. So if you say, "Is the sky pure today?" if you ask that question, there's nothing grammatically wrong with that. If you type that into something like Word, it's not going to flag it as incorrect. But these errors are commonly made by non-native speakers. So to address this problem, we created a tool called AucChecker, published in WIST in 2008, which uses a corpus of speech to detect these awkward phrases and then suggest alternatives. And it suggests alternatives using a technique similar to spell checkers. So it flags "the sky is pure today" as awkward, and then it will search for synonyms, insert and delete words, and then try to find more acceptable phrases and then suggest that to users. So this is a really valuable tool for non-native speakers, but you could also imagine using it for doing things like writing a journal paper for an area that you're not familiar with. If you have a backing corpus of articles from that particular area, it can suggest more appropriate phrases as you're writing the paper. I mentioned we did some work with license agreements. So how many people here actually read license agreements when you install software? Yeah, no one. So you see license agreements like this. They're all bold. They're all caps. They're just really not that compelling to read. We've done a lot of work with instrumentation recently where we collect data about how people are using software. We want to make people aware of the data that we're collecting and then the privacy implications for that. And as such, we have a consent agreement, but it looks like this. People gloss over when they see it. They don't read it, so they don't really understand the privacy implications of our technology. So what we did is we went to the supermarket and we bought copies of magazines like People Magazine, Us Weekly, Star Magazine, all these sensationalist magazines you see at the checkout counter, because they're financially incentivized to get your attention with their visual designs. And so we systematically harvested the visual designs from these magazine covers and then applied them to license agreements and came up with a consent agreement that looks like this. With this type of agreement, with this type of visual design, we've been able to significantly increase reading time from essentially 0 seconds to about 30 seconds, and we've also been able to demonstrate that people comprehend more from the actual license agreements. And we've done this without changing any of the underlying text. We've just visually redesigned them and augmented them. So that gives you a sampling of some of the work that we've done in our lab. So what is today's talk about? Well, there are 3 messages that I want to get across. One is that people use a very small percentage of feature-rich applications, and I'll show this in the in-GIMP data set. This is something that you probably have come across if you've done instrumentation work yourself here. The second piece is that we've been able to infer high-level tasks from very low-level command data using clustering techniques. And this is really encouraging because we haven't had to build models of how people actually perform tasks to get these high-level inferences. And finally, we're using this data to develop a new community-driven social customization for feature-rich applications. And I'll show you some mock-ups that we're working with right now for this new application. OK, so about 3 years ago now, we took GIMP, which is the open source equivalent to Photoshop, and we instrumented it to collect data about how people use the software in a day-to-day practice. Right? This is a common practice in the industry. It's very common with web apps, but open source developers don't do this. They haven't done it in the past, and so they don't really have a clear understanding of how their software is used in the wild, and we wanted to provide that information to them. At the same time, we wanted to make a public corpus of how people use software because you just don't have these things available. Right? So again, it's common practice for corporations to go and collect data about how their customers use their software, but for obvious business reasons, they don't make this data public. We think this is, but we think these types of data sets are important and they're valuable for research purposes, and so we want to create a public corpus of how people actually use software on a day-to-day basis. So we instrumented GIMP. We put it out there in the wild. We got slash-dotted, and we quickly gained a good-sized user base. All the data we collect is publicly available at www.ingimp.org, so anyone can download it, analyze it, do whatever they want with it. There are 5 different types of data that we collect with this instrumentation. We collect system characteristics, so the type of operating system they're using, the number of monitors they have, the resolution of their monitors, the commands they use, but we don't collect command parameters, so we can't recreate their sessions perfectly, or at all, I should say. We collect interface events, so when windows come up on the screen, when they're resized, moved. Fairly unique, I think, to this instrumentation effort, we collect document characteristics. So we collect the size of the images, the number of layers in the images, but we also collect histograms describing the images. Right? So if you look at these 2 histograms, you can get a sense of the types of images that users are likely working on. So you look at this histogram here, and there's not, there's only 3 peaks there, not a lot of variability. So they're probably working with something like a line art or creating a logo. Whereas you look at a histogram like this, and it's pretty clear that they're working on something like a digital image. Right? So gathering these high-level summarizations of the documents are useful to us so we can better understand their tasks and what people are doing with the tool. Finally, we collect activity tags. So when the application first starts up, we have the splash screen to remind users that they're using an instrumented version of the software. And users can optionally enter in tags describing what it is they intend to do with the software. What was interesting is that 75% of the significant users of our software actually entered in activity tags, which provided a wealth of information describing how people actually use the software. And I'll come back to this a bit later in the talk. So after 2 years, we had over 800 installations, over 5,000 log files collected, over 500,000 commands collected, and then the software was open for over 3,500 hours. So given this data, I want to break it down into these categories. I want to first talk about our need to identify significant users. I want to then characterize the session, so how people use the software. I'll get into command use and some of the intricacies or nuances in characterizing command use. And then I'll talk about our clustering technique to infer higher level tasks. This summary is available or will be available in GI 2010 in June. OK, so one of the issues that we have to deal with is that the software is free, so anyone can download and try it. Right? So once we get some press, there are going to be a lot of people who are just going to want to download it, try it out, and kick the tires, and then just forget about it. So we want to identify a significant user, someone who's actually using the software in a meaningful way. And the criteria that we came up with to identify a significant user is anyone who's used the application and saved a document on at least 2 separate days. Using this criteria, we're left with about 200 users who contribute about 4,200 log files. So these are about 25% of the users who downloaded and installed it, but they constitute, or they created 75% of the log files. So it's a pretty good filter.
So Michael, what percentage of users do the actual task tagging? And if someone does a task tag, do they continue to do it, or is it sporadic?
Right, so good question. So the question is, what percentage, or which of the users do the tagging, and then how often do they do it? So 75% of these 200 users entered in activity tags at least once. And the median case was that they only entered in once. Now, probably one of the reasons that was the case was because the design was such that once you had entered in an activity tag, the next time you started up, that same tag was already filled in. And so it wasn't blank. And so they probably just got in the habit of saying, oh, OK, same tag, hit return, I'm going to start the application. So we can improve that design a bit to prompt people more to get that information.
When a new tag comes up, does it by default accept it, or does it reject it unless they confirm it as happening again?
So when the splash screen comes up, whatever tag you entered in last will automatically be filled in there. And that will be recorded if they just hit return. Yeah, it might cause us a little bit of error, exactly. So when we were looking at the tags, we were mostly looking at them as examples of the different types of activities they were performing. But we'll come back to these tags and actually show that they have some use with the clustering algorithms too. OK. So to quickly describe the users, the characteristics, we had users from 15 different time zones, 9 different locales. But predominantly, they were English and French-speaking users of the software. 73% were Windows users, 27% were Linux users. 99% only used one monitor. And this was kind of surprising for us because it's an image manipulation application. And when you think about people doing things like on Photoshop and so on, you kind of have this vision of these large multiple monitors. In our data set, most people only had one monitor, and then the screen resolutions themselves were quite low. So the majority of, or the highest percentage of users had 1280 by 1024, followed by 1024 by 768, followed by 1280 by 800, and then below that, a wide range of resolutions. Yes?
Wouldn't you suspect, though, that the people who were investing in larger second monitors would also invest in Photoshop?
Yeah, I mean, there's probably a correlation there. If you're buying Photoshop, you're probably going to have greater hardware buying resources as well. But that said, we were still kind of taken back by these resolutions. These are kind of, smaller than I would expect from modern computer users. All right, so to characterize their sessions, the median session length was 9 minutes, and this was with idle time removed. So we defined idle time as 120 seconds. This was a really conservative estimate of idle time. So people were not using the software for great lengths of time. In those sessions, they had a median of 24 command invocations per session, with a median of 6 different commands per session. So we're using medians because pretty much every single distribution we have looks like this, right? There's zip distributions by and large for the data we collected. So people are not using it for very long periods of time. They're using very few commands when they sit down and use it. And their sessions have very few command invocations, right? So very light usage of the software.
So where does 2 minutes come from?
The idle time for the 2 minutes?
Yeah, I mean, you think that maybe better heralds of a task completed, like saving or 2 minutes, you took a cup of coffee, phone call, multitasking, reading email.
Right. So we looked at the idle periods of time, and I think the median idle period of time was I want to say 30 or 40 seconds. I'd have to look at the paper to get that. And so we thought, well, 2 minutes is a fairly conservative estimate. So anything over 2 minutes or over, we're just going to call that idle time.
That could really change the way you cluster and infer tasks if you were wrong about that.
So, right. So in terms of inferring tasks, so we have about 9 minutes with 120 seconds for idle time. But even so, disregarding that, people are using only 6 different commands with 24 command invocations per second, and they're only working on 1 or 2 documents at a time in a session, right? And so what we've basically inferred is that a single session is fairly equivalent to a task, right? And you might have some, margin of error there, where they might be doing, 2 tasks or 3 tasks in a particular session, but by and large, their usage is pretty simple. It's pretty straightforward.
Because it also gets into how you define a task, right? So some might think, I have a task of taking this photo off my digital camera, making it smaller, fixing it up, and sending it to somebody, my relative in email, as one task.
Right.
Versus make the contrast better.
Right. So hold on to that a bit, and so we'll look at some of the activity tags that people entered so you get a sense of the kind of tasks that people are performing. So there are 13,500 images that people worked on. The median resolution of the images was 800 by about 700. The median number of maximum layers in an image was 1, right? So again, fairly simplistic uses of the software. They're not working with very large images either. So what about these activity tags? What did people say they were actually doing with the software? Well, people were doing things like graphic design, map making, resizing PNGs for web graphics, Garmin icon editing, OpenSim avatar texturing, screenshots of software to be used in educational material, coloring digital art, cell shading, video game graphics, gel analysis, a wide range of activities. But really, when you look across these, a lot of them are content creation tasks. And the commands that people were frequently using sort of back this up as well. People also communicated to us when they were just trying things out, so that they let us know that you could ignore this particular session if you want to. So they would say things like, I'm just opening up to see in GIMP. People also tried to kind of break the system. So as I mentioned, all the data that we collect is made publicly available, and you can go to the InGIMP website and see summaries of the data. So people try to do things like insert cross-site scripting attacks with their activity tags. We successfully, or we anticipated this, and so all of our web code is robust to these types of attacks right now. All right, so to summarize what we saw in terms of the sessions and the command usage, people were performing relatively quick targeted tasks, though there was a wide range of reported tasks. And as I mentioned, the tasks were much more oriented towards creating content rather than heavy use of filters. So while there's a very complete set of filters available in the software, people were rarely using it in our data set. So I want to switch now to discussion of command use. So what were the commands people were using, and how can you summarize these things? So one of the most popular questions you have when you collect this type of data is, well, what are the most popular commands? But this question is fairly problematic for direct manipulation applications like an image editing software application, because you have tools like the paintbrush or pen or eraser that will dominate command counts. All right, so every time you use a paintbrush, every time you use the pen or eraser, that's going to be counted as a command. And so what we do is we break up the command counts into a couple different dimensions. So we have raw counts, which are just the total number of commands that were recorded on the undo stack. We have user counts, which are the number of users who have used a particular command. Session counts, so the number of sessions that a command has appeared in. And then no repeat counts, where we take repeat uses of commands and squash them down to just a single instance. What's nice about these different dimensions is that they give you different perspectives on the software tool and then how commands play into people's activities. So user counts give you a sense of the popularity of a command across the user base, whereas session counts provide you a sense of how critical or essential a command is across all tasks. So with these different dimensions in mind, here's what we found in terms of the most popular commands. Here we have just the raw command counts. And so you can see the direct manipulation tools dominating the top ranks of command counts. So add anchor for working with the pen tool. Undo, not a direct manipulation tool, but very popular. Paintbrush, bucket fill, smudge, clone, pencil. These tools are going to be those ones where you're repeatedly invoking them. And in this particular column right here, we sort of bring this trend out. So these percentages right here indicate how many of the invocations are due to repeated invocations of that command. So you use add anchor and then you use add anchor again. So you can see right here the number one command, add anchor, it attributes its ranking to 96% of those counts being repeated counts. Undo, smaller, but then when we get back to the direct manipulation applications like paintbrush, bucket fill, you see that a large percentage of those invocations are due to them repeatedly invoking that command. So again, this is not a great measure to understand what's popular in the application. Instead, if you rank things according to user rank, then you get a clearer picture of what tools are important to the community. And so with this particular ranking of commands, we see undo, paste, paintbrush coming up to the top. And you can see there's not a great correspondence between the raw command counts and then the rankings and the user counts. So this is, we think, a more useful perspective in understanding what features of the software are useful to the entire community. Another way you can look at the command use across your user group or your user base is to consider their command vocabulary. So the number of different commands that people have used across all sessions. The median command vocabulary for this particular user group was 27 out of about 500. So people only invoked about 27 different commands across all sessions. And what was interesting is that there's very, very little overlap in command vocabularies between people. Right? So people have very idiosyncratic uses of the software. And this is borne out here in this particular table. So right here we have the proportion of users who use a particular command. So there's only one command that 90 to 100% of the users use, and that's undo. And that trickles down, so 70 to 80% use 4 commands in common, 60 to 70 use 5. The majority fall in this 0 to 10% category where there are very few commands that are used by more than 0 to 10% of the user population. Right? So very idiosyncratic command vocabularies across our user base. So I mentioned that we'd like to be able to go from this low-level data to a higher-level understanding of what people are actually doing with the software and be able to identify clusters of people who are doing similar things with the software. So going from this low-level command data, oh yeah, question?
Yeah, before you get into that, in Photoshop, I don't know, in Photoshop, you have multiple ways of doing the same thing, depending upon your own personal preferences and your expertise and stuff. Is that true in GIMP, and did you account for that to try to merge similar things together?
Right. So there's definitely the possibility of doing the same task multiple ways with the software. And in fact, the clustering stuff I'm going to talk about right now helps to sort of overcome that and glob people together even if they have slight differences in how they use the software. So again, we have this fairly low-level description of how people are using the software by looking at frequency counts of commands. We'd like to be able to pop up to a higher level and say what people are actually doing with the software. And we need to be able to figure out how people, we need to be able to take care of that problem that you mentioned just now about where people might perform the same task using a slightly different command set. But we need to begin with a good approximation of what constitutes a task. And again, we found that the sessions in our data set are relatively short, so about 9 minutes long. People are working with relatively few images in a session, so usually 1 or 2. And so from this, we're going to infer that a session is a reasonable approximation of a task. Given this approximation, what we're going to do is cluster similar sessions together to overcome the small differences that people do have when performing the same task with different commands. And we're going to use John Wissel, Charlie Clark's, and Adam Ashkin's clustering method that was published in CIKM 2009 to perform this clustering operation. So how do we do this clustering? We take a session of commands. We convert it into a feature vector where every command is represented by the number of times that command was in a session. Right? So in this case, we have brightness contrast once, crop is repeated 3 times, and so on. And so every session is converted into this feature vector of the number of command counts for that particular session. We then apply 11 well-known clustering techniques to those sessions. Okay? And we're creating 7 clusters of sessions using each of these clustering techniques. Okay? What we want to do is we want to identify the best clustering of the data, but we don't really have a good objective function. So we're going to use 7 clustering techniques to cluster the data. Then we're going to treat these clusters as labeled data to train a classifier. And then the classifier that's the most accurate in being able to take sessions and then classify them into the clusters, we're going to call the best clustering of the data. Okay? Now, if you talk to Charlie Clark about this, he says, this sounds weird and counterintuitive, or there's no real good mathematical argument we can make right now to say why this works as well as it does, but it actually works really well. So in our case, we take these cluster sessions that result, identify the 12 most common commands using the session metric, and then consider these to be common tasks. Okay? So this is the result of clustering via that algorithm I just showed you. And what you can see when you look at these clusters is fairly well-identified tasks. So in this particular cluster, you see commands like scale, crop image, undo, levels, resize image, convert image to grayscale, rotate, rotate again, unsharp mask, which actually sharpens the image. These right here are commands that are doing basic manipulations of images, right? So you're getting digital camera images, you're touching them up slightly, you're rotating them, cropping them, whatever. Okay? Compare that to cluster 2, where we have things like rectangular select, paste, move floating selection, anchor floating selection, crop image, scale image. Here you're working with pieces of images, right? So in GIMP, when you have floating selections, this means that you've pasted content into the image.
Are these ordered?
Sorry?
Are these ordered?
Are they ordered in terms of the frequency? Yeah.
No, user action. These are just clusters right now. They're not. You don't have any temporal information in them. Right?
Oh no, that's right. Yep. Okay. The third.
Have you tried to do clustering by temporal?
We haven't tried to do clustering by temporal, and one of the reasons is just because of the direct manipulation tools, right? So the most common occurrence is that a command is followed by itself. But if you have other ideas for the temporal clustering, I'd love to hear them. This particular set right here, you see a lot of text tools, right? So you can infer that people are doing graphic design. Here we have add anchor, path, so people are working with Bezier curves likely. And as you move on, you see more painting-like tasks. So we want to be able to validate these clusters to assure ourselves that it's actually a reasonable technique. And this is where the activity tags come back in and are critical. So we take the activity tags that people entered in to describe how they're going to use the software. We stemmed them, and then we counted the number of sessions the tags were reported in for each of the clusters. So we take this cluster right here, the first cluster where we had scale, crop image, convert image to grayscale, and so on, and we look at the descriptions that people use to describe those particular sessions. We see things like resize, photo, crop, web, screenshot, edit, scan, screen, correction. Right? So they're doing basic image manipulation and correction tasks with the software in those particular sessions. Take this cluster right here where we have the text tools, and people are reporting doing things like logo, photo, text, make, edit, design, create, web. So more graphic design types activities. And so what's nice about these activity tags is they've provided some validation for this clustering technique and also backed up our hunches of the types of things that people were doing based on the commands in the clusters themselves. So we think this is a useful mechanism to go from the low-level command data to higher-level inferences of actual activity. All right, so to contextualize these results, so our users are using less than 2% of the interface. So most of the functionality that's offered in the interface is not needed to accomplish their common tasks. These results are in line with previous studies. So Saul Greenberg had a lot of work in the late 80s and early 90s where he had very similar results. Linton, who looked at Word, also had very similar results. People use a very small portion of the interface, and they have fairly idiosyncratic command vocabularies. So what these data really do point towards are the idea that mixed initiative, adaptable, or adaptive interfaces really are going to be useful with today's feature-rich applications. So given this, we're starting to reconceptualize the GIMP software and how it could be designed. We're moving away from this idea of having an interface have a hierarchy of menus or containers or toolbars or palettes, and towards a more task-oriented perspective with social customization built into it. So we're taking this idea of the tool palette right here, where you have every single tool available, even though you might only use a small portion of it, and moving towards a design where people specify what activity or task they want to perform, and then the interface provides just those tools to perform that particular task. Okay? With that, we're also incorporating the notion of tutorials. So the user community is very adept at creating tutorials for the software, whether it's commercial software or open source software. So this, for example, is a tilt-shift photography Photoshop tutorial that someone has created and posted on the web. What we're doing is designing the capability to create these task sets where you choose just the commands that you need to perform that task, but then also provide the ability to have documentation associated with that task set. So I choose a photo editing task set. It loads the palette up with the tools necessary to perform that task. And I can optionally hit the information button to get a description of how I actually complete that task. So we're merging, again, the idea of these community-generated tutorials into the actual application. Users can, of course, edit these task sets. So you can see right here an example of the actual dialogue used to create these task sets and edit them. So you name them, tag them, provide a description, and then choose the commands necessary to perform that particular activity. Now, how do you choose these things? Our current design, we have a task set manager. This is very much inspired by Firefox's extension manager, but also the package managers you see for Linux. So when you start up the software, you're not going to have any task sets installed by default, but you click on the Manage button, and you can describe what it is you want to accomplish, and then get a list of particular task sets matching that search. You check the ones that you want, and then they'll be installed in the application for you to be able to switch between them at runtime. So it's a different way, again, of thinking about how the application provides its functionality. Here we're trying to really cast tasks as the central organizing feature of the application. All right. And I think I've talked through all these points, so I'll move through it. One of the things that you can imagine as well is once you get to the point where you have tutorials being incorporated into the application, you can imagine also having extensions to web browsers such that you can write up a tutorial on the web page and then have a link so that you can install the particular task set from the web page into your application right there. Right, so you can actually have XML descriptions of what tools you actually need to perform this task set within the web page, and then it will load it into your actual application later. Okay, with this particular approach, it should lead to better labeled log data. Right, so again, if people are now explicitly specifying what it is they want to do with the application in order to get the customization of tools, we're going to be able to record that data into the log file and have even better labeled data describing what it is that people are doing. And the other nice aspect of this particular design is now we can start to make recommendations at the level of tasks rather than low-level commands. So you might be doing tilt-shift photography, and with that particular task, we might be able to find other people doing tilt-shift photography and be able to recommend things like high dynamic range photography. And so, again, we're going to be able to work with recommendations at a slightly higher level than people typically have worked with in the past. OK, to summarize, the in-GIMP data set and our analysis of it really corroborates prior work. So typical application use is really limited to a handful of applications. People have highly idiosyncratic command vocabularies. And all of these things really argue for things like mixed initiative interfaces. The clustering technique that we've applied, we've been able to show can yield higher level tasks without the need for explicit a priori models. We think this is a useful method, again, for going from the low level data to high level inferences about what people are doing with the software. And we're in the process of developing a community driven social customization tool. That is it for now. I'd like to thank our funding sources and then I'll acknowledge everyone who's worked on this project. So Andrea Bunt, who's now at University of Manitoba, Ben Lafreniere, who's my PhD student working on this, Jordan Stinson, who's done a lot of coding of the adaptable version of GIMP that we're working on, John Whistle and Charlie Clark, who've done the clustering work. Thanks.
Any reactions or comments?
So it's really close to Joanna McMurray's work that she did with us back in like 96, 97 time frame.
Yep.
And she gave them the interface for the self-adapting. You had to make it add the features you wanted. I mean, can you comment on what's different?
Yeah, so Joanna is actually working with us through this big NCE project that's now going on in Canada. One of the things that, there is obvious overlap with a lot of the work that she's done in the past. One of the things that we think is attractive about this is that we're going to be able to throw this out there and get hundreds or thousands of users, whereas prior systems haven't really been tested with that large of a user base. Sorry?
You have the clustering too, which is
Yeah.
So I got a little confused in the clustering because I'm used to the clustering being exclusive. So back on the example clustering you gave, for
Yes.
The command undo was in every cluster.
Yes. Okay.
So was and rect select is actually in all of them except for one.
Yep. Okay. So yeah, this algorithm is kind of not completely transparent when you walk through it the first time. But what we do again is we forget about the fact that there are a bunch of different clustering algorithms, right? So first we cluster all sessions based on similarity with one another, okay? And we end up with 7 clusters, okay, of sessions, okay? Once we determine which of the 11 sets of clusters is quote unquote the best clustering of the data, then what we do is we take the 12 most common commands and across the sessions for a particular cluster, right? And so therefore you do have overlap, right? And which is desirable in this case, right? Because you can have commands that are essential to different tasks, and so you don't want to just bin them in one set of one set of commands.
So one comment on that is you could use that analysis to create a palette of common commands that are always available, and the specialty commands that come up with tasks.
Yeah, I think that's a good approach.
Well, and it might make some of the clustering look better if you identified commands which were application level, like save or undo,
Right.
That you would assume get used in every session.
Right.
And that might just make the rest of the clustering a little bit more accurate.
Yep. Yep. Anything else I can answer?
Any feedback on the other work, the first book you mentioned on the contract reading, any evaluation studies or?
So yeah, I mean, we've run a couple different experimental studies on the license agreements. Let me get way back there. Yep. So we've done a pair of studies on this, and people like them. People say that, yeah, it looks like you're actually trying to communicate this information to me, and so I take the time to read it. What these things tend to do is increase intrinsic motivation to read the license agreements, whereas if you have things like mechanisms which force you to scroll all the way to the bottom before you can click I accept, that tends to be a deterrent because you look at the dialog box and you see that you can't click the accept button, so your new task becomes figuring out how to enable that. So it forces you, or it compels people to spend even less time on the license agreement, so they can get the radio button enabled.
I don't see whether it's the best interest for the software manufacturers to ask the user to read more, spend more time in those agreements.
Well, that's true. I mean, even researchers sometimes.
Well, spend no time and always accept will be less trouble. But if it is a user's menu, I think it's a different story.
So there are companies like EA who's having to deal with lawsuits because they've installed rootkits with their games, and people haven't taken the time to read the software agreements, and so people are kind of upset at that. And so there are reasons that companies may want people to actually read these license agreements. Also, if you look at Google has a privacy center with a lot of information about what data their various services collect. And so they're making an effort to try to better inform their customers about their particular practices. There are other company examples out there. So there's this a manufacturer of a web-based image manipulation application, and they have a license agreement with a summary column next to it. And again, they just find it to be good customer relations to try to be transparent and open about what the contents of the license agreements are. But also think about when you rent a car, for example, or even today when I had this agreement I had to assign. Typically what you have is someone standing next to you going through the agreement saying, and this particular paragraph says this, and this paragraph says that, right? In some sense, this agreement style is encoding that particular practice in the agreement itself.
Michael was referring to his release for the video today.
Yeah.
Had a chance to explore our approach to it.
Are you going to do any other applications? You talked about continuing that work.
Right.
Is it continuing in GIMP, or is it applying that work to some other area, like word processing or no?
Right. So we're just focusing right now on GIMP. We're familiar with the code base. We're familiar with the domain, and so we want to have one success before we start to worry about other applications. So in our conversations with Joanna, one thing she has mentioned is that she's found it exceedingly difficult to have these kind of tasks defined for word processors. And so I wonder if there might be something unique about image manipulation where, or not, if we're going to run to the exact same problems where it's really hard to define very discrete tasks that are useful to a lot of people.
So when we get to do at least a B application, A/B compare with the same methods, clustering and so on, to see what you learn from that.
Yeah.
Specificity of the application type.
Yeah, we just don't have any other corpora to work on.
I have a suspicion, because of the comparison between what you had in your clusters versus what I do in Photoshop, that a lot of this comes from the fact that you have an audience that's using it in a very simplistic fashion, which you maintained without really getting into it. You never said everybody uses it simplistically.
Right.
But I know for a fact that there is a group of people who use Photoshop in a completely different fashion than what you showed there.
Absolutely. So there might be another contributing factor to that, and that is that anyone can download GIMP and use it because it's free.
Exactly.
And so some people, when you talk to them about using GIMP, they'll say, well, I use it because, I'll use it in cases where I'm at a friend's computer, I need to do something. They don't have Photoshop. I don't want to get a pirated version of it, so I'm going to download GIMP, do the simple thing, and then erase it, right? Or they might do very simple tasks like open up an image and convert it from a TIFF to a JPEG, right? Which you can do with GIMP because it's free, but you wouldn't spend $500 for Photoshop to do that very simple task. And so I think part of the reason we see such simple uses of it is because there is such a low barrier to acquiring the software and applying it to these fairly trivial tasks.
Oh, thanks.
Thanks.